So there's a concept called root mean square that is supposed to simplify things for us. Basically what it means, the root mean square voltage is the same as if we take the voltage max that we were just talking about and divide by the square root of 2. So other ways that people do this, they take the root mean square and that is actually, if dividing by square root of 2 is about the same as multiplying by 0.71 times the voltage max. Okay, so we have this current, and we have this max and min current, this V max. The root mean square is around here. So why do we talk about this? Well, in an alternating current, if you, again, draw the voltage, the average voltage in one period here is 0, because there's the same amount of positive and negative voltage. So, instead of talking about an average there, we're trying to get just kind of a general idea of how much voltage there is, because most of the time, the voltage is not actually up near the maximum or down at the negative maximum. So what they actually do is they look at V squared. So every height along these curves, they square them. And if you take that function and square it, you get something that kind of looks like this. Now it turns out that the V squared average is exactly half here. So you could say it this way: the V squared average is exactly 1/2 of the maximum squared. So the root mean squared is, if you take the square root of the average of V squared, and in this case we know that the V squared average is the same as this, so the root mean squared is actually the square root of 1/2 of the V max squared. And if you square root these things individually, there you have it. Root mean square is the same as the maximum voltage divided by the square root of 1/2 is actually the same as the square root of 1 over the square root of 2. And so that's kind of a quick explanation. It's a way of getting kind of an average amount of voltage out of it. And we get it because we want to have something that kind of represents most of the strength of the voltage, but if you just look at the average of the regular voltage, it's 0. Okay, so for example, in a house, you have a voltage marked at 120 volts. This actually is the root mean square of the voltage. So what is the actual maximum voltage that you would see in an AC circuit at home? Well, what we can do is we can go back to the top here and we get to choose one of these two. I'm just going to use the bottom one for simplicity. Root mean square is equal to 0.71 times the V max. Now I'm trying to find V max, and I'm going to put in 120 here. If I divide by 0.71 on both sides, the actual maximum voltage that you would see in the circuit is I'm getting about 170 volts. Okay, now something to note here. It's the same exact thing with current. Remember that current is in with phase in the voltage here. And if you want to know kind of the average, the root mean square of the current, you're going to take the max current and divide by root 2. Now another thing here, I'm talking about power. Power is the same in a DC circuit as current times voltage. And we didn't really go into this too much, but here it's kind of important because you'll see a lot of things like light bulbs that are rated in power, in watts. So over on this side, you'll have watts. Okay. Now, something to know here. Excuse me. If current is the same as V over R, and let's say I multiplied both sides by V, well, then this side would be power, and this side would be V squared all over R. Now in an AC circuit, this is the average power, and this is the root mean square of the voltage. So if you just need an estimate, or just need to use simple numbers on the package, this would be what you would use. So, for example, if you have a 60-watt light bulb, and you're using a 120 volt root mean square voltage source, you run a current through this light bulb, and there's some natural resistance going on. That natural resistance comes from the fact that the current going through the light bulb is heating the filament, and that is losing some heat. And so that's some heat dissipated. And that's basically what a resistor does. It slows down current, and it will create heat. So we can actually use this here to figure out what is the ohms rating on this light bulb. So we have a 60-watt light bulb. The root mean square is 120 squared. And then we have the resistance. I'm going to flip these two. That's a little math trick by cross-multiplying, basically. Now when I work this out, I'm getting an answer of 240 ohms. So this is a concept we're going to get into more. Some elements in an AC circuit actually act somewhat as a resistor because of the alternating current.